Hello friends, welcome to our channel Text Master. In this video, we will learn how to design a switching circuits, which this type of circuit is used in bulb, UV controllers or anything else. So we will type on our browser is Mosfet and chopper working details and circuit theory. So there are multiple tabs open, so we will click on second website. What is Mosfet working and its applications? The Mosfet metal oxide semiconductor field effect transistor is a semiconductor device that is widely used for switching purposes and for amplification of electronic signal. In electronic device, a MOSFET is either a core or integrated circuit where it is designed and fabricated in a single chip because the device is available in very small sizes. The introduction of MOSFET device has brought a change in the domain of switching in electronics. Let's us go with a detailed explanation of this concept. What is MOSFET? MOSFET is a four-terminal device having source, gate, drain, and body terminal. In general, the body of MOSFET is a connection with the source terminal, thus forming a three-terminal device such as a field effect transistor. MOSFET is generally considered as a transistor and employed in both the analog and digital circuits. This is the basic introduction of the MOSFET and their general structure of this device is given: gate, drain, source, body. From the above MOSFET structure, the functionality of MOSFET depend on the electrical variations happening in the channel with along with the flow of carriers, holes or electrons. The charged carrier enter into the channel through the source terminal and exit via the drain. The width of the channel is controlled by the voltage on the electrode, which is called gate. The charge carrier enter into the channel through the source terminal and exit via the drain. The width of channel is controlled by the voltage on electrode, which is called gate, and it is located in between the source and the drain. It is insulated from the channel near an extremely thin layer of metal oxide. The mass capacity that exists in this device is the crucial section where the entire operating across in this source, gate, drain. Source, gate, drain. A MOSFET can function in two ways: depletion mode, enhancement mode. What is depletion mode? When there is no voltage across the gate terminal, the channel shows its maximum conductance. Whereas when the voltage across the gate terminal is either positive or negative, then the channel conductivity decreases. For example, gate, source, drain. Enhancement mode. When there is no voltage across the gate terminal, then the device does not conduct. When there is the maximum voltage across the gate terminal, then the device shows enhanced conductivity. Working principle of Mosfet. Depletion mode and enhancement mode. The main principle of Mosfet device is to be able to control the voltage and current flow between the source and the drain. It works almost like a switch, as the functionality of the device is based on the MOS capacitor. The MOS capacitor is main part of MOSFET. The semiconductor surface at the below oxide layer, which is located between the source and drain terminal, can be inverted from p-type to n-type. The semiconductor surface as the below oxide layer, which is located between source and drain terminal, can be inverted from p-type to n-type by application of either a positive or negative gate voltages respectively. When we apply a repulsive force of the positive gate voltage, then the holes present beneath the oxide layer are pushed downward with the substrate. The depletion region populated by the bound negative charge, which is associated with the acceptor atoms. When electrons are reached, a channel is developed. The positive voltage also attracts electrons from the source and drain region into the channel. Now, if a voltage is applied between the drain and source, the current flow freely between the source and drain, and the gate voltage control the electrons in the channel instead of positive voltage. If we apply a negative voltage, a whole channel will be formed under the oxide layer. P channel. The P channel MOSFET has a P channel region located in between the source and drain terminal. It is a 4-terminal device having the terminal as gate, drain, source, and body. The drain and source are heavily doped p-type region, and the body or substrate is of n-type. The flow of current in the direction of positively charged hole. When we apply a negative voltage with repulsive force at the gate terminal, the drain is of P region. The depletion region populated. When we apply a negative voltage with the repulsive force at the gate terminal, then the electrons present under the oxide layer are pushed downward into the substrate. The depletion region populated by bound positive charge, which is associated with donor atom. The negative gate voltage also attract hole from the P source and drain region into the channel region. So this is the depletion mode of P channel: gate, VG, drain, VDS, ID, N channel. So this is P channel. When P channel VG applied is negative, so the negative electrons attract the hole, so separated long. Gate, drain, source, body, depletion region, and The N-channel Mosfet has an N-channel region located in between the source and drain terminal. It is formed having a terminal as a drain gate source. In this type, field effect on the drain and source are heavily doped and region and the substrate or body P-type region. The current flow in this type of MOSFET happens because of negatively charged electron. When we apply the positive voltage with repulsive force at the gate terminal, then the holes present under the oxide layer are pushed downward into the substrate. Apply the positive voltage, then the gate terminals, then the holes present under the oxide are pushed downward and oxide. And so we again learn from above paragraph the substrate or body are of p type. Okay. Push downward into the substrate. The depletion region is populated by bound repulsive force at the gate terminal. Then the holes present under oxide layer are pushed downward into the substrate. The depletion region is populated by the bound negative charge which are associated with the acceptor atom. Upon the reach of electron, the channel is formed. The positive voltage also attracts electrons from the N source and drain region into the channel. Now, if a voltage is applied between drain and source, the current flow freely between the source and drain, and the gate voltage controls the electron in the channel. This is a positive voltage. Positive voltage. If we apply negative voltage, then a whole channel will be formed under oxide layer.